Captain Rob Smith of BoatTest.com. I'm here with Solas Lynn and Rick Norgard from Solas Props. We're going to learn a little bit about the Solas Props today and why they make a difference. Thank you for coming here, Solas.
Thank you.
And Rick?
Thank you, sir.
Talk to us a little bit about the props. Now, we were looking at this center hub system, and one of the things that is outstanding about this is you may not know it, but you already know Solas Props. And you're making a ton of props out there. And how do these make a difference?
Yeah. I think everybody, like Float Talk or the Boatex, they use plastic. But we use the rubber mount on the metals. The metals actually is aluminum alloy and extrusion, so it is strong and lightweight compared they use the bronze. And our rubber, because they have a soft, so when they put inside the hub, when you tight the nut, they become tight, and they still go inside, but they are no move this way.
So the wobble that people are feeling at low end is absorbed by this rubber being in there and tightened up, so you don't get that movement that everybody's hearing at the low end.
Yes, the plastic usually they have a tolerance, so it's difficult to control because especially the aluminum, the surface is just casting. If the surface too rough, sometimes they are too tight, cannot go in perfect, and then they have the tolerance. And they are too loose or the too tight, they just cannot fit. So we think the rubber is the best way. We use the metal to get the torque and the rubber to absorb the vibration. So the customer will find it's low vibration and very smooth and durable also.
Now, Rick, is this something that's going to be used in your props across your product line, or is this specific for some of the props that you have here?
Captain Rob, we're introducing this for the V6 stern drive applications first, and then we'll move down into the V4 four-cylinder applications, the 75 up to 135 horse motors. And we're going to have it available in our 3-blade aluminum and our 4-blade aluminum propellers and our 3-blade and 4-blade stainless steel propellers.
Wonderful. Let's take a moment and talk a little bit about how you develop these props and some of the materials you use to make these props, because the durability and the performance, I think, has a lot to do with the metals and the design, as well as how they're cut and made.
We use the squeeze cast method. We're the only propeller company in the world that does that. Dr. Solas has pioneered this and patented the method. And what we do is we push the aluminum up the die at lower speeds than at die casting in a water-cooled die, and we control how fast it goes in there, and we push all the air out of it. So we can make the metal thinner, the propeller thinner, and stronger at the same time. And if you have a sharper knife, it cuts better, and it goes through the water, correct. More horsepower, more performance.
Yeah, when we cut the propeller, you will see a lot of the others die cast, a lot of the air bubble inside. So when you weld, you will find it difficult to weld in. But the Solas, when you cut, the structure is so density and there are no air bubble.
What kind of equipment are you using to come up with some of these ideas? I know we talked about the fact that you came up with some of the hub design on the airplane on a ride because you couldn't sleep. Now, how do you take that and put that in action to come out with some of the best props that we're seeing out there?
Oh, actually, originally is hydrodynamic. I designed the hard form, the propeller, those kind, how to get performance. So my engineer is a good team, and they design the good propeller for us. And the question is how to make propeller precision and strong enough with the thinner blade. So we we find one way is use we call the squeeze machine. Actually, die is vertical, and the aluminum is they have piston from the bottom, and we use the hub as the size of the gate. Usually, die caster is very small gate from the side or from the center, but they use the high speed, high pressure injection, and we know propeller we need to use the 3% magnesium alloy and a very low silica. So this type of material is non-corrosion, and they get the strength when you make correctly. But it's difficult to casting. When you use another way, like a gravity casting, is can always miss wrong because they are no fluid. They are very sticky metals. Yeah. So we use squeeze.
So it sounds like to people listening to us here, it sounds like he's extremely well versed in this and should be, because you truly are a doctor with a PhD in this kind of technology. So you are a doctor of propellers here.
Yeah. So because I am engineer and I know what kind of technology can make it is low cost, good, strong. Like this piece, we use the forged. We have the tool to forge and then machining. And this also we develop the tool to stamp, and so we actually right now the material is up almost. Stainless is 3 times, more than 3 times. Aluminum is 2 times, and we still not so adjust our price too much because we try to develop something very low cost and efficiency.
So you're holding down the cost of development so that to the end user, they're getting a better device, stronger material, better performing, and trying to keep it at the same price that they're used to seeing in the past.
If you look at the aluminum propeller, Solas always thinner competitor because we still get the strength.
Yeah, thinner's better, but it's got to have the strength, or you're going to end up with a 2-blade prop somewhere along the line, right?
Yes.